Hello class, this is the next video covering activity 3.3. We had just finished problem 2A and 2B, where we had the car that was initially worth $22,000 and it depreciated over time by 30%. We came up with an equation, right, that would give us the value V of the car at any given time, T. And the next thing we want to do is we want to talk about rate. See, the value for B in this equation was a growth or decay factor. Remember, it's decay if the value of B is between 0 and 1. So 0.7 is between 0 and 1. So this is a decay factor. But what if I ask for the decay rate? Well, that's the purpose of this video. So if you look at the bottom of your page, looks like page 223, we have the decay rate. It says the car depreciation problem in activity 3.2. This should actually say 3.3. Stated you've just learned that the value of the car should depreciate by 30% per year. The 30% is the percent decrease per year. It is also called the decay rate and is designated by the letter R. And the next page, I think I have a cleaner version of this in Word. There we go. Okay, so we're still looking at the same material, just this is in a Word document instead of a PDF. Okay, so again, let's make this a little bit bigger. Here we go. All right, so again, it says since the 30% of the value is lost, we reason that 70% of the value remains. We were able to multiply the previous year by 0.7 to get the next year. So if you remember from our table, every time I multiplied the value by 0.7, I got the next output, right? So 22 times 0.7 gave me 15.4, times 0.7 gives you 10.8, and so on. Okay, so the 0.7 was our decay factor. So the question is, how do I determine the decay rate? Is there a formula I can use? Well, for decay, this B equals 1 minus R will work. Okay, so I think you're going to want to write that down. So I'm going to write this on the side here. Okay, so for decay, we have this B equals 1 minus R. For growth, it's actually going to be B equals 1 plus R, but we'll discuss that in another video. So thinking about our car problem, remember the decay rate was 30%. So if I write 30% as a decimal, you end up with B equals 1 minus 0.30, which gives me 0.7. And that's how we come up with our B value, or our growth or decay factor. Okay, so now they give us an example. There's nothing for us to do. It's just an example. They give us a function. I see that my B is going to be this 0.94, and they ask us to find the rate, right? So my decay factor is 0.94. Why is it decay? Because 0.94 is greater than 0, but less than 1. All right, so I wrote this over here, right? So if B is between 0 and 1, we have a decay factor. To find the decay rate, we're going to substitute the 0.94 into B and solve for R. Right? So we're going to sub in the B here, and we're going to solve for R. So after we do some math, some basic algebra, we end up with R equals 0.06, and as a percent, you'll write 6%. Okay, let's take a look at example 3. Right, they give us the decay rate. So in this case, they're giving us R, and they want us to find B. Okay, again, if this is the formula for decay, well, we know what R is. R is the 1.9%. So remember, you have to change 1.9% to a decimal by moving the decimal place 2 places to the left. And that's where this 0.019 comes from, right? To change 1.9 to a decimal, you move the decimal point 2 places to the left. So when you perform the math, 1 minus 0.019, you're left with your B. Right, so your decay factor is the 0.981. All right, so now here's work for us to actually do. Question 1A. if the decay rate is 3%, what is the decay factor? Right. So again, they use the word decay a couple of times. So you know B equals 1 minus R for decay. So if we substitute the 0.03 in for R and solve for B, we have something that looks like this. Right? B equals 1 minus 0.03, and you end up with B equals 0.97. I apologize for my handwriting. I'm using a stylus on a touch screen, so maybe I can actually just type in the answer here. Let's try this. Here we go. B equals 0.97. I think that looks a little bit better. Make that bold. Make that an 18 font. There's our answer. Right? Question 1b. If the decay factor is 0.89, what is the decay rate? So, again, we're still going to use this B equals 1 minus R. And now we know B, right? See, in question 1a, they gave us R. Anytime you see a percent sign, that's R. 1b, there is no percent sign, so that means this 0.89 is the decay factor. So I'm going to substitute 0.89 in for B. And I have 0.89 equals 1 minus R. So I have to solve this for R. So I could subtract 1 from both sides. And you see I have negative 0.11 equals negative R. And if I divide both sides by negative 1 or multiply both sides by negative 1, you end up with R equals 0.11, which is the same as saying R equals 11%. Okay, so that would be my decay rate. What's the decay rate? R equals 11%. And I prefer you to write it with the percent sign as opposed to simply 0.11 or R equals 0.11. Question 2. It says, all right, they give us a function here. What is the decay factor? So the B is your decay factor. Right, that's going to be your 0.96. Right, that comes right from here. Now, to find your R, remember, you're still going to use this formula, B equals 1 minus R. And you've been given that B is the 0.96. So I'm going to write 0.96 equals 1 minus R. Okay, and then I have to solve this for R. So I suppose I could subtract 1 from both sides. And you see I get negative 0.04 equals negative R. And again, I can multiply or divide both sides by negative 1. And you're going to get R equals 4%. Right? So I get R equals 0.04. And again, to change a decimal into a percent, you move the decimal 2 places to the right. And you end up with 4%. Last question, number 3. So you've just purchased a car for $17,000. Write an equation that represents the value of your car T years from now. Okay, so first let's think about the formula or the form of an exponential function. So the form of an exponential function is this y equals ab to the x, where a is the initial value and b is the growth or decay factor. So we know the initial value. The initial value of the car, because it's brand new, is $17,000. So we can write, so I've replaced the A with 17,000. And now my B is the growth or decay factor. Now, we know the car is depreciating, so we know we need the decay rate and decay factor. And we know the formula is B equals 1 minus R for decay. Right, so we know B equals 1 minus R. It looks something like this. And again, let's make that look a little nicer. Right, and this is for decay. So we have to just substitute. The 20% is our R. If we substitute the 20% into R, we can solve for B. All right, so I replace my R with 20% as a decimal. Remember, move the decimal 2 places to the left and drop the percent sign. So 1 minus 0.20 is 0.8. Okay, so our B is this 0.8. So I can now rewrite this equation. And here's my final answer. And okay. All right, so this is the equation that would model this situation, right? If I ask, what's the value of the car 2 years later? You'd put in a 2 for x and you'd solve for y. If I said, what's the value of the car 5 years from now? You'd place a 5 in for x and you'd solve for y, right? This gives you the value of the car for any given number of years. All right, thanks for watching.